Hello everyone. I welcome you all to the lecture 6 of this course, Construction Methods and Equipment Management. So, in this lecture, we will be discussing about the replacement analysis of the equipment. So, let us have a recap of what we learnt in the lecture 5. In the lecture 5, we had a discussion on how to estimate the equipment cost using caterpillar method and the purify method. Now, this is the outline of the present lecture. So, in this lecture, I will be discussing with you what are all the different ways of defining the equipment life, and I will also highlight on how to estimate the economical useful life of the equipment. We will be working out some illustrations on how to estimate the economic life of the machine. So, equipment life. So, basically there are different phases in the equipment life, as everyone knows. So, it starts with the purchase of the machine. Okay, we purchase the machine first, then we start using it. As we use, with the age of the machine ages, you can see that the machine will be subjected to more amount of wear and tear. So, once it is totally worn out, okay, when it comes to the end of the useful life of the machine, we go for the replacement of the machine. So, generally we replace at a particular point when the machine is totally worn out. That means it will not be economically feasible for us to economically repair it and use it. So, in that particular stage, what we do is we either abandon it or scrap it or sell it at a reasonable price, okay, and replace the old machine with a new machine. So, these are the common phases in any equipment life. So, for a profitable equipment management, there are certain decisions which are very important. So, one such decision is a replacement decision, whether to replace your old machine with a new machine or not. If at all you decide to replace, when to make the replacement. So, what is the optimum replacement time? So, these two are very important questions, or these two are the important decisions which are to be made accurately from profitable equipment management perspective. As I told you earlier, we cannot just cling on to the old equipment. Just because the old equipment is just doing its function in your project site, we cannot just cling on to it, because as the age of the equipment increases, it may be worn out, or it might have become totally obsolete, because so many new competitive models would have come into the market with a better productivity and even lower maintenance and repair cost, and with lower operating cost, and I can say with better advanced features, with more ease of operation, with more safety features, with enhanced productivity. So, okay, when more added features are available for the competitive models which are available in the market, it is not economically advisable to just cling on to the old equipment at the project site. So, we should find the optimum replacement time and replace the old machine with the new machine, even though your machine is functioning in the project site. So, just because it is doing its function, we should not just stick on to the old machine. We should find for the optimum replacement time and replace the old machine with the new machine, which has a better productivity than your old machine. So, to make this replacement decision, so we need some knowledge on how to estimate the economic useful life of the machine. So, what is this economic useful life? Okay, I will be discussing more in detail in the upcoming slides. Basically, economic useful life is a time period during which the cost associated with the machine is minimum. Okay, the total cost, the cumulative total cost associated with the machine is minimum. Okay, if you are going to optimize a production with respect to cost, we talk from minimum cost point of view. If you are going to optimize a production with respect to profit, then we have to talk from maximum profit point of view. In that case, we have to define the economic useful life from profit perspective. That means the economic useful life is a time period during which the profit will be maximum for the particular machine. Okay. So, the time period during which the profit is maximum or the cost is minimum, both these things refers to the economical useful life of the machine. So, if you know this economical useful life of the machine, at the end of this useful life of the machine, we have to replace our old machine with a new machine, because we never want the profit to get reduced. Okay. So, that is a common business policy. We do not want the profit to be reduced, or we do not want the cost of holding the machine to increase. So, we have to determine the economic life, and at the end of economic useful life, we have to replace the old machine with the new machine. Okay. How to determine that? We are going to discuss that in the upcoming slides. And the next one what we are going to discuss is, once you have decided to replace your machine, so we have to look for the alternatives. What are all the alternative machines available in the market to replace my current machine in the project site? Okay. So, there are some terminologies we need to know. The currently installed machine at the project site, that is called as defender. Any currently installed equipment or the asset, we call it as defender. and the proposed equipment which you are considering for the replacement, okay, the potential replacement, that is called as a challenger. Okay. So, these terminologies you should be aware of. So, basically in the replacement analysis we will compare the cost of the defender and challenger, and with that we will justify the replacement of the defender with the challenger, and also we will find the right time when to replace the defender with the challenger. So, these are the different cases or the problems which we are going to solve in the upcoming slides. Okay. One is we will be determining the economical useful life of the machine, okay, that helps me to decide when to replace the machine. Other one, I will be able to compare my defender with challenger. Okay. So, I can compare it with the different alternatives. Okay. So, there are so many analytical models or guidelines available which helps you to make the comparison and to make the decision. Okay. So, to choose the best alternative for the replacement. Okay. So, that is what comes under the replacement analysis. We are going to discuss that in the upcoming slides. Okay. So, now let me define you what is the equipment life. There are different ways to define the equipment life. This graph shows you the pictorial presentation of the equipment life, you can see. So, you have the replacement age in the x axis and you have the profit in the y axis. So, basically you can see that one is, this is the physical life of the machine. Physical life refers to the entire life of the machine, entire life, you can see in the picture. That means it is a period between the moment you purchase the machine and the period between the moment you abandon or scrap or replace your old machine with a new machine. Okay. So, that refers to the entire life of the machine, that is the physical life of the machine. So, when we replace it or when we scrap a old machine, whenever it is totally not economical to hold that machine, it is of no utility value to you, it is totally broken down. So, beyond that it is not possible for you to repair it and use it economically. At that particular point of time we totally abandon it and replace it the old machine with a new machine. So, this refers to the physical, the total life of the machine. So, when is the end of the physical life? The age at which the machine life is worn out and no longer work productively. We say that machine life has come to the end. So, the machine is totally worn out and it won't work productively for you. Its productivity is very poor. Okay. So, in that case you can say that it has reached the end of the life, and this physical life will vary for different machines. Okay. As we discussed earlier also, it depends upon the type of the equipment. Obviously, it depends upon the type of the equipment. There are certain sophisticated equipments which are not subjected to much wear and tear. Say a simple electric motor, it is not subjected to much wear and tear. So, those equipments you can see the physical life will be more. Similarly, the equipments which are subjected to less mobility, those equipments may last for a longer time. Okay, its physical life may be longer. So, it depends upon the type of the equipment, also it depends upon the nature of the project working condition. Okay, we have discussed this example earlier. The same machine, an excavator, one which is working in the quarry, handling the short rock pieces, the other one which is just handling the ordinary earth in a project site. So, both will have a different physical life because the amount of wear and tear to which both the machines are subjected to are totally different. Okay. So, the nature of the project conditions is going to decide the length of the equipment life. Okay. Another important thing you need to know is the preventive maintenance, the care you show towards your machine. So, if you put some efforts for the preventive maintenance of the machine, then your machine will last for a longer time. The small amount of efforts we spend for the preventive measures, for the preventive maintenance, okay, it will save you from the major breakdown of the machine, and it will save you from the major repair and the maintenance cost or major equipment cost. It will save you from the major the operating cost of the machine. Okay. So, that is why it is always advisable to put some efforts for the regular preventive maintenance. So, you have to have a maintenance facility where you have some labor engaged for the regular maintenance of the machine, where you will be doing the periodic checkup of the machine or the timely service of the machine. So, you have to do the daily cleaning of the machine. If you are going to take care of your machine in a proper manner, it will last for a longer time. So, the length will vary depending upon the care you show towards the machine. So, this is what is called as the physical life of the machine. It refers to the entire life as you see from this picture. So, the next what you are going to see is your profit life. So, basically we know that we have spent a lot of money for purchasing the machine. So, we have invested huge amount of money for purchasing the machine. Okay. So, during the initial the periods, you can see that your machine will be just recovering. Okay, it will be just recovering whatever cost you have invested in it. okay, for procuring the machine or purchasing the machine. So during the initial phase of the equipment, you can see that it will be just recovering whatever cost you have invested in it, depending upon the cost of your machine. But after a particular time, it will start earning more than its associated cost. It will start earning more than its ownership and the operating cost. That means it has entered into the profit zone. So this is called as the profit life. Okay, you can see the profit life of the machine. So this is the profit life of the machine. So you can see that during the initial phase, okay, it is just recovering the cost what we have invested in. After that, it starts earning more than the cost. That means it has entered into the profit zone. Now it reaches the maximum profit. After that, what happens? The profit starts reducing. Why the profit start reducing? Because as the age of the equipment increases, it is subjected to more amount of wear and tear. So its productivity will start reducing. Okay, its repair and the maintenance cost will start increasing. Okay, so most of the time it will be spending in the repair yard. So you can see that its profit will start reducing. And finally, at the end of the profit life, you can see that it will start entering into the loss zone. So it is entering into the loss zone. Okay, you can see. So below this 0 is your loss zone. So it has entered into the loss zone because it spends most of its time in the repair, or its repair and the maintenance cost has increased. Okay, so basically in a business we always try to be in the profit zone only. Okay, so generally they advise that before the machine enters into the loss zone, we have to replace the old machine with a new machine when its major parts are functioning, so that I can sell that equipment at a reasonable price to someone who is interested in buying it. Okay, so before it enters into the loss zone, it is basically advisable to replace the old machine with the new machine. So profit life is nothing but the life over which an equipment can earn a profit. Okay, so as I told you, after recovering the cost of its purchase, the machine starts earning more than its cost. That means it has entered into the profit zone. So the end of the profit life, you can see it spends more time in the repair yard. So that means it will enter into the loss zone. So before that, it is better to replace the old machine with the new machine. So the next important thing what we are interested in is your economic life, which I discussed in the initial part of this lecture also. Economic life, here I am going to discuss with respect to profit. Okay, so here I am talking about optimization of production with respect to profit. So economic life is a part of your profit life. Economic life ends when the profit is maximum. You can see the economic life ends when the profit is maximum. Generally the equipment owners, okay, from the business perspective, we can see that we never want our profit to get eroded. Okay, so we want to always have the maximum profit. We don't want the profit to get eroded. Okay, so that is why your economic life ends when the profit is maximum. Okay, so if you wanted to maximize your profit, it is better to replace your machine at the end of the economic life itself. Okay, so before your profit gets reduced due to increase in maintenance and the repair cost, before that itself, replace the machine. Replace the machine at the end of the economic life of the machine. So basically, economic life refers to the time period with maximum profit if you are going to optimize your production with respect to profit. And the economic life ends when the profit reaches a maximum value, because I don't want my profit to get reduced at all. I don't want my profit to get eroded at all. Okay, so in that case, at the end of the economic life itself, let me replace my old machine with the new machine. So here I am talking about optimization of production with respect to profit. The same economic life I can discuss with respect to cost. In that case, the graph will be inverted. Okay, so whenever the cost is minimum, so this is the cost curve. Okay, the total cost curve. So whenever the cost is minimum, that time period I have to replace the machine. So I don't want to hold my machine beyond the particular period where the total cost associated with the machine is going to increase beyond this. So I don't want to hold it beyond the economic life. Whenever the cost is minimum itself, I will replace my old machine with the new machine. So these are the different approaches. But one thing we have to note it is the optimization with respect to profit is little bit difficult, because it is generally difficult to extract the profit data of an individual equipment from the entire equipment fleet. Okay, it is difficult to extract the profit data, as well as from the total project. It is difficult to extract the profit data of the equipment alone. So that's why people always prefer to optimize, because they find it convenient to optimize with respect to cost. the cost estimation is easier when compared to the profit estimation. So coming to the replacement analysis, okay, so now we are going to estimate the economic life of the machine. We will be working on some illustration on how to estimate the economical life of a particular machine. So as I told you, to make an accurate estimation of the economic life, to do the accurate replacement analysis, I need to include all the cost components. So we have discussed about different components of the ownership cost and the operating cost. So we have to consider all the cost involved in the equipment cost estimation. Okay. So some of these costs we have not discussed earlier, we are going to discuss now. One is the inflation cost, other one is the downtime, other one is the obsolescence cost. Inflation, everyone knows, it is nothing but the loss in the buying power of a currency. Loss in buying power of your currency. Say for example, if I have purchased a machine for 10 lakh rupees 5 years before, the same machine I cannot purchase it at 10 lakh now. Obviously the cost of the machine would have increased with time. So that is the effect of inflation. So whenever we consider about the replacement, when we plan for the replacement, when we do the replacement analysis, this increase in cost with time due to inflation should also be incorporated in the cost estimation. So we have to consider the inflation effect on the cost estimation. So other one is downtime, which we are going to see now. Downtime is nothing but your machine is not available for working productively. Either it has broken down, okay, it has been sent to the repair yard for the repair, okay. So this generally refers to the time period of non-working of the equipment due to repairs. Time period of non-working of equipment due to repairs. Basically, as the age of the machine increases, it gets worn out. So many parts gets worn out. So many times you can see it will be sent to the repair yard, okay, for the service. Okay. So with increasing age, you can see that the downtime cost will also increase. Okay, it is obvious. So when the machine is sent to the repair yard, when it is not available, also we are incurring the cost. So this is what I told you the initial part of the lecture also, that even when the equipment is idle, okay, we are incurring some cost associated with the machine. We always incur, we have to bear this ownership cost, whether the equipment is operated or whether the equipment is idle. Irrespective of whether it is operated or idle, we are going to bear some fixed ownership cost associated with the machine. So that has to be taken into account. Other one is the operating cost. Okay, even though the machine is in the repair yard, you have to pay the wages for the operator. So we are bearing some operating cost. And another thing is your productivity loss. Since the machine is not available for the productive job, we are facing the loss in productivity. So because of that, there will be some increase in cost. So that is another important thing. So basically, to explain that more clearly, say for example, your machine has spent some sufficient time in the repair yard. Okay. So because of that, we are going behind our production schedule. Okay. So once the machine comes back from the repair yard to the project site to resume the service, okay, so we are already behind the schedule. So what we have to do, we have to now increase your the number of operating hours, or you have to increase the operating time, you have to extend the working hours, you have to hire more labor, okay, or even you have to employ more machines, so that I can bring back my productivity level to the original level of the productivity. So for that I have to incur some additional cost. That cost is taken under the loss of productivity. Okay. So the loss of productivity results in increase in the production cost, because in order to bring back the original production rate, we need to engage more equipment and extend the operating life of the equipment. So that results in some additional cost. This is what we are going to estimate in the upcoming illustration, how to estimate the cost associated with the loss of productivity of the machine because of the downtime of the machine. Another important thing which we should not overlook is the loss of the use of dependent machines. Okay. See for example, when the machines are working in team, say for example your excavator and the truck, they are working together. Okay. If the excavator breaks down, okay, so the truck will also be idle. Okay. So the ownership cost, the operating cost and the operator wager cost of the truck and the loss in productivity of the truck, everything should be taken into account when you estimate the downtime cost of the excavator also, because they are dependent machine. Similarly, your scraper and a pusher which are working in team, when the scraper breaks down, the pusher will be idle. So the associated cost of the pusher should be taken into estimation of the downtime cost of the scraper. Similarly, you have a concrete mixer machine. Okay, if the concrete mixer machine breaks down, so what will happen? The dependent machines are your pump, your transit mixer, your RMC transit mixer, all these are dependent machines. So when this breakdowns, all these associated machines will be idle. So their cost should be accounted when you estimate the downtime cost. So all these things we should keep in mind when we estimate the downtime cost associated with the machine. So basically, the downtime cost is usually expressed as a percentage of the operating cost. Okay, so in different literature they express it different way, as a percentage of the operating cost, or the percentage of the equipment rental charges, okay, or the percentage of the equipment cost. Okay, so it is expressed in different ways in different literature. Okay, but basically what you need to know is what is downtime. It's a time the machine is not available for a job. Say for example, your machine availability is 90% of the total time. If its availability is 90%, then obviously the downtime will be 10% of the total time. I am talking about the time. So if the availability of the machine is 90%, then the downtime which is not available is 10%. So the next important cost which we should consider when we do the replacement analysis is the obsolescence cost. Okay, so this we discussed earlier also. As a machine gets older, it becomes obsolete. Why it becomes obsolete? Because it's worn out already, its productivity would have been reduced, its maintenance and repair cost would have increased. Okay, at the same time you can see in the market there are competitive models in the market which have better productivity at lower operating cost, and also maybe there are so many advanced features which gives you more ease of operation, more safety features, okay, with enhanced productivity. Okay, so when there are so many models available in the market, competitive models available in the market, despite that, when you are sticking to your old machine with your low productivity, then we are facing actually some loss. Okay, so there is some increase in cost associated with that. That is called as obsolescence cost. So newer and more productive models supersedes the older ones, leading to reduction in value of the machine and the marketability of the old machine. So basically it refers to the obsolescence, refers to the loss in value of the machine with time. So due to depreciation, as well as the loss in marketability of the machine. So this obsolescence can be either technological obsolescence or market preference obsolescence. Technological, just now I told you, where due to the loss in productivity. There are many competitive models with better productivity in the market, but you are sticking to the old machine with a very low productivity. So what is the cost associated with it? What is the loss we are facing because of that? That is technological obsolescence. The other one is little bit difficult to quantify because the customer taste changes with the time. Okay, so when they see for many advanced features in the new models, their taste changes with the time. Even though your machine may be performing well, okay, but the customer taste would have changed. So that is market preference obsolescence. So there are different types of obsolescence. So basically this obsolescence value is expressed as a percentage of equipment cost. Okay, so this factor I can get it from literature for different types of equipment, for different operating conditions, for different conditions, I can get the obsolescence value. So we can make use of that for estimating this obsolescence cost. So we have discussed about the different components of the equipment cost estimation from the replacement analysis perspective. So as I told you earlier, for replacement analysis we should consider all the components of the equipment cost so that to make an accurate estimation of the replacement timing. Okay, so we should consider all the components of equipment cost, including the downtime cost, obsolescence cost, the effect of inflation, everything should be considered so that we can get an accurate picture of what will be the optimum replacement time. Okay, so now let us work out the illustration so that we can have a better understanding on how to estimate the economic life of the machine. So hope you remember what is the economic life of the machine. Economic life is nothing but the time period during which the cost associated with the machine is minimum. Okay, so if you are going to optimize your the production with respect to cost, then we have to go for the minimum cost. If you are going to optimize your production with respect to profit, then you have to go for the period with maximum profit. Okay, so basically that is what is economic life. Economic life means it's a time during which the cost of holding the machine will be minimum. Okay, so beyond the economic life, you can see that there will be increase in cost associated with the machine, either due to increase in the operating cost, that is repair and the maintenance cost, or increase in downtime cost, or increase in obsolescence cost, all these things will be resulting in the shooting up of your total cost of the machine. Okay, so which is not desirable. That is why when the cost is minimum itself, we should try to replace our old machine with the new machine, so that we don't enter into loss. Okay, so now let us work out an example. In this example, we are going to see how to estimate the economic life of the machine. Okay, so basically, so here we are going to estimate the economic life for a track mounted French shovel, okay, whose the purchase price is 35 lakh. So the machine is expected to last for 8 useful years, and the depreciation is assumed to follow double declining balance method. So we are going to follow double declining balance method to estimate the depreciation, and at the end of the 8 years, you will be able to sell the machine at the cost of rupees 7 lakh. That means the salvage value of the machine is 7 lakh. Okay. So due to inflation, you can see that annual increase of the average cost of the equipment is approximately 6%. That means the machine cost is going to increase by 2,10,000 every year, okay, due to the effect of inflation. So this also need to be considered during the replacement analysis, and the cost of investment is 15% per year. Okay. So this you can consider as a percentage of the book value of the machine. Then the equipment is going to operate for 2000 hours in a year. So the annual usage is given 2000 hours. So the other parameters needed for the replacement analysis are given in the following tables. Okay, we are going to discuss that. So we have to estimate the economic life of this machine. Okay, so what are all the other parameters needed for the replacement analysis, which are given as the input data for this problem? Let us see. So for calculating the hourly maintenance and the repair cost, downtime cost, and the obsolescence cost of the machine, we have to use the following values. Okay, and the equipment cost is given approximately as rupees 900 per hour. Okay, so every year maintenance and repair cost is given for the entire useful life of the machine. Okay, so you can see that the annual maintenance and repair cost is increasing with the age of the machine. As the age of the machine increases, you can see that maintenance and the repair cost is increasing. And another thing, I hope you remember what is downtime. Downtime is nothing but the non-availability of your machine for the productive work. So it may be either due to the breakdown of the machine, okay. So mostly it is due to the breakdown of the machine. Machine may be spending its time in the repair yard and it won't be available for the productive job. So that time is called as the downtime of the machine. So in order to estimate the downtime cost, we express it as a percentage of the operating cost of the machine or the equipment cost of the machine. Okay. So you can see that with the increase in age of the machine, your downtime cost is also increasing. As the machine becomes older, you can see the time it spends in the repair yard will be more. So the downtime percentage is more. Okay. And another thing, as I told you, when the machine is not available for the productive job, okay, so you will be facing some loss in productivity. Okay. So that productivity factor is also given. Okay. So maybe for the first year there is no change in productivity, but from the second year onwards you can see that there is loss in productivity of the machine with increase in the downtime of the machine. Okay. So how this loss in productivity is going to result in increase in the cost of the machine, we are going to estimate in the upcoming slides. Okay. So another thing to be noted is your obsolescence cost is also important. Okay. As age of the machine increases, it becomes obsolete. You know that. So there may be different reasons for the obsolescence, either due to technological obsolescence, that is due to wear and tear, its productivity may get reduced, okay, or it may be even due to market obsolescence. The customer taste would have changed. The customer may be opting for more advanced machine with more ease of operation, with more safety features, with more updated technology. Okay. So it means if your machine had gone obsolete, there are so many competitive models in the market which are having updated technological features. Okay. So these obsolescence factors are available from the literature for different types of equipments, and you can see that with increase in age, your obsolescence factor is increasing. Okay. For the first year, it is 0. It means your machine is not obsolete. Okay. By the end of second year, you can see there is some percentage of obsolescence. Okay. And your obsolescence factor increases with the age of the machine. Okay. It is clearly evident. You can get this data from the literature for different types of equipment. This we are going to use it in the estimation of obsolescence cost. Okay. So now let us work out the cost associated with the machine from the replacement analysis perspective. Okay. So as I told you, we are supposed to consider all the components of the cost associated with the machine, so that you can have an accurate estimation of the optimum replacement time. Okay. So, first we are going to estimate the depreciation and the replacement cost associated with this the machine. Okay. So, as I told you, due to inflation there is an increase in cost with the machine every year. So, it is given in the, as input data in the problem that the initial cost of the truck is 35 lakh, okay, and the annual increase in the cost, you can see that it is 2,10,000 every year. Okay, annual increase in the cost is rupees 2,10,000, okay, due to the inflation. Okay. So, after 1 year, if we want to replace the particular machine, the increase in the cost will be 2,10,000. So, initial cost is 35 lakh. At the end of 1 year, if you want to replace the machine, so you have to spend 37,10,000 to replace the machine. Okay. So, there is an increase in cost of say, okay, 35 lakh plus 2,10,000. So, at the end of first year, if you would like to replace, the cost will be 37,10,000. Okay. Similarly, at the end of second year, if you would like to replace, then the cost will be say 39,20,000. So, every year the cost increases by 2,10,000. Similarly, at the end of third year, if you want to replace, you have to increase further by 2,10,000. Okay. So, your cost will be 41,30,000. So, like that every year the cost increases by 2,10,000 due to inflation. This you have to take into account when you do the replacement analysis. Okay. Another important thing you need to see is every year the machine is depreciating, there is a loss in book value. So, in this problem we are going to estimate the depreciation using double declining balance method. So, I hope you remember what was the formula used for the double declining balance method to estimate the depreciation. It is nothing but 2 by n into book value of the previous year, 2 by n into book value of the previous year. Say for the first year, okay, first year I have to estimate the depreciation now. Okay. D1 is nothing but 2 by n into book value of the previous year. Book value at the end of the previous year is nothing but the book value at the beginning of the current year. Okay. So, both are same. Book value at the end of the previous year is same as the book value at the beginning of your current year, for which you are calculating the depreciation. So, the useful life of the machine is n is 8. 8 multiplied by book value at the end of the previous year. It is nothing but for the first year it should be the initial purchase price, 2 by 8 into 35 lakh. 2 by 8 into 35 lakhs is nothing but your depreciation is 8,75,000 rupees. Okay. So, this is the depreciation for the first year. Now, you calculate the book value at the end of the first year. At the end of the first year is nothing but book value at the beginning of year is nothing but 35 lakh minus your depreciation for the first year. Depreciation for the first year is 8,75,000. You can see that 8,75,000. Okay. You subtract both, you will get the book value at the end of first year. It is nothing but 26,25,000. Okay. So, book value at the end of the first year. So, to get that you have to subtract the book value at the beginning of the first year, okay, and the these two and the depreciation for the first year. If you subtract these two, you will get the book value at the end of the first year. Okay. So, this is how you calculate. So, that is why it is given here. You can see that book value for the current year is nothing but book value at the end of the previous year minus the depreciation for the current year. Okay. So, the book value at the end of the previous year is same as the book value at the beginning of the current year. Okay. Now, let us calculate the depreciation for the second year. Okay. So, depreciation for the second year is nothing but 2 by n, 2 by 8 into book value for the at the end of the previous year, book value at the end of the first year. So, 2 by 8 into book value at the end of the first year is 26,25,000. Okay. So, this gives me the depreciation value for the second year as 6,56,250 rupees. Okay. 6,56,250. Okay. This is the depreciation for the second year. Now, book value for the second year is nothing but book value at the beginning of the second year or book value at the end of the first year minus depreciation for the second year. Okay. So, what is the book value at the end of first year? It is nothing but 26 lakh 25,000, 26 lakh 25,000 minus your depreciation for the second year. Depreciation for the second year is 6 lakh 56,250, 6 lakh 56,250. So, if you subtract both, you will get the book value for the second year as 19 lakh 68,000, okay, 750. So, this is the book value for the at the end of second year. Okay. So, hope you understand. So, how are you calculating that? So, basically if you subtract the book value at the end of the first year minus the depreciation for the second year, you will get the book value at the end of the second year. Okay. So, one more example, sample calculation I will show, so that your understanding will be better. So, now we are going to calculate the depreciation for the third year. Depreciation for the third year is nothing but 2 by 8 into book value of the second year at the end of second year. So, 2 by 8 into book value at the end of second year is nothing but 19 lakh 68,750, 19 lakh 68,750. So, that gives you the depreciation for the third year as 4 lakh 92,187.5. Okay. Now, you calculate the book value at the end of third year. It is nothing but book value at the end of second year minus depreciation for the third year. Okay. So, what is the book value at the end of the second year? Okay. At the end of second year is this one, 19 lakh, okay, 19 lakh 68,750 minus depreciation for the third year is 4 lakh 92,187.5. So, if you subtract both, you will get the book value for the third year as 14 lakh 76,562. So, that means, so you are to estimate the book value of the third year, you have to subtract the book value at the end of the second year and the depreciation for the third year. If you subtract these two, okay, you will get this 14 lakh 76,562.5. Okay. So, this is how you are going to estimate the book value and the depreciation for the 8 years. Okay. So, the remaining calculations you can do. Now, let us see what is the loss associated with the replacement. As I told you, due to inflation, there is an increase in cost every year. Okay. So, at the end of first year, I told you there is an increase in cost of 2,10,000. Now, your new cost is 37,10,000. Okay. There is an increase in cost, there is a loss actually. Similarly, there is a decrease in value of your machine due to depreciation with time. So, at the end of first year, the book value is 26,25,000. That means, from 35,000, it has gone down to 26,25,000. Similarly, the initial price has increased from 35 lakh to 37,10,000. Okay. If you subtract both these two, you can find the loss on replacement. Okay. If you subtract both these two, you can find the loss on replacement. Okay. So, basically, you can see here, see basically at the end of first year, if I wanted to replace, the cost of the machine is 37,10,000. Okay. Due to inflation, from 35 lakhs, it has increased by 2,10,000. Okay. But at the end of the first year, if I replace my old machine with a new machine, the inflow I can get is only 26 lakh. Okay. Because your machine is depreciated, your machine is depreciated 26 lakh 25,000. Okay. So, the difference you can see that 37 lakh 10,000 minus 26 lakh 25,000, this is your loss. Okay. Loss is nothing but 10 lakh 85,000. This is your loss. Loss on replacement if I replace a machine at the end of first year. Okay. Similarly, if I replace a machine at the end of second year, at the end of second year, you can see the machine has increased in cost by 39 lakh 20,000 due to inflation, but the book value has gone down to 19 lakh 68,750. So, this is your inflow actually. So, actual loss will be for the replacement at the end of second year will be 19 lakh 51,250. Okay, 19 lakh 51,250. So, this is your loss on replacement at the end of second year. Okay. Similarly, you can calculate for the third year, 41,30,000 minus your book value is 14,76,562. If you find the difference between these two, you will get the loss on replacement as 26,53,437. So, already this is on cumulative basis only. Now, you find the cumulative use of the machine. Every year, you know that the machine is being used for 2000 hours. Okay, the annual usage of machine every year is 2000 hours. So, you find the cumulative use of the machine, say for second year 2000 plus 2000 is 4000. For third year, okay, 4000 plus 2000 is 6000. Now, for the fourth year, the cumulative use will be 6000 plus 2000 hours, it is 8000 hours. Like that, you find the cumulative use of the machine. This entire replacement analysis will be on cumulative basis. I will explain you later. Okay, we have to do it on cumulative basis only. So, I will explain the reason later. Now, you find what is the cumulative cost per hour. Cumulative cost per hour is nothing but the cumulative cost on replacement. Okay. So, the cumulative cost on replacement, so you can see here the cumulative cost on replacement, okay, at the end of first year is 10,85,000 divided by the use of the machine is 2000 hours. It gives me 542 rupees 0.5. That means, at the end of the first year, the depreciation and the replacement cost associated with the machine is 542.5 per hour. Okay. Similarly, at the end of second year, if I wanted to find, okay, so the depreciation and the replacement cost, you can see that it is 19,51,250. At the end of second year, the cumulative use is 4000 hours. Okay. So, now the cost per hour will be 487.81 per hour. So, that means, if I am going to hold this machine with me for 2 years, so the cost per hour associated, okay, cost per hour associated for the 2 years is 487.81. Okay. So, the replacement cost associated with this machine, okay, per hour is 487.81 for 2 years. So, we are calculating on the cumulative basis. Okay. Similarly, for the third year, it is nothing but 26,53,437 divided by 6000. It gives you the cost as 442.24 per hour. Okay. So, if I am going to replace this machine at the end of third year, you can see the cost per hour associated is 442.24 per hour for the past 3 years. So, like this you calculate the depreciation and the replacement cost for the 8 years for the entire useful life of the machine. So, one thing you can see that the depreciation and the replacement cost is decreasing with time. Okay. As the usage of the machine increases, as the cost is distributed over a greater period, as the cost is distributed over a greater period, you can see that the cost per hour is getting reduced. Okay. So, mostly the ownership cost is getting reduced with time, because as the usage increases, because the cost is getting distributed over a greater period. Okay. Now comes the investment cost. So, this investment cost includes all the costs associated with the investment, like the interest you pay for the loan, your insurance, taxes, license fees, everything we are adding it under investment. So, it can be calculated as a percentage of the equipment book value. Okay. So, in this problem, the cost of investment is given as 15% per year. Investment cost is given as 15% per year. Now, we are going to calculate the investment cost for the entire useful life of the machine. Okay. And we will calculate the investment cost as a percentage of the book value of the machine. Here we are taking the average book value for every year, average book value of every year you are going to calculate. So, I need to know the book value at the beginning of the year and book value at the end of the year to find the average book value of the particular year. Okay. So, obviously, book value at the beginning of year is a purchase price 35 lakh, book value at the end of every year you can get from the previous table. You have calculated the book value at the end of every year. Okay. So, this column you can use it for the investment calculation. Book value at the end of year, every year can be obtained from this table. Okay. So, you are going to use it. And another thing, as I told you, book value at the end of first year is same as the book value at the beginning of the second year. Similarly, book value at the end of second year is same as the book value at the beginning of third year. So, it goes on like this. Now, you find the average book value for every year. average book value for every year is nothing but, say for the first year we are calculating, you calculate the average 35 lakh, okay, plus 26 lakh 25,000. Okay, this is at the start of the year, this is at the end of the year. You find the average, okay, add it, okay, divide it by 2. Okay, when you divide by 2, you will get the average. So average is found to be the 30 lakh 62,500 rupees. Okay, average book value for the first year is 30 lakh 62,500. Okay, now you calculate the investment cost. Okay, so investment cost is nothing but 15% of average book value of the particular year. So 0.15 into average book value is nothing but 30 lakh 62,500. Okay, so what will be the investment cost? It's nothing but 4 lakh 59,375 for the first year. Okay, so this is how we have to calculate the investment cost for every year. Okay, so one more sample calculation I will show so that you will understand better. Now the average the book value for the second year, same way, the book value at the beginning of the second year is 26 lakh 25,000 plus 19 lakh 68,000, the book value at the end of the year. Now you add it plus then the sum you divide by 2, you will get the average. Okay, that average is nothing but your 22 lakh 96,875 rupees. Okay, so this is your average book value. For this you calculate the investment cost. So investment cost is nothing but 15% of the average book value, 0.15 multiplied by 22 lakh 96,875. So this gives me the investment cost as 3 lakh 44,531.25. So this is your investment cost for the second year. Okay, so like this you can calculate the investment cost for all the years. Okay, now you find the cumulative investment. Okay, so you can easily find the cumulative investment. So investment for the first year, okay, add it with the second year, you will get the cumulative investment at the end of second year. So cumulative investment at the end of second year, add it with the third year investment, you will get the cumulative investment at the end of third year. Okay, so like that you keep on adding, you will get the cumulative investment. Now the cumulative usage, you know, every year the usage is 2000 hours, add it, 2000 plus 2000, 4000, 4000 plus 2000, 6000. So keep on adding it, you will get the cumulative usage of the machine for every year. Okay, so the entire replacement analysis is on cumulative basis only. Okay, so now you can see the cumulative cost per hour. So how do you find the cumulative investment cost per hour? So cumulative investment cost is nothing but for the first year 4,59,375 for the first year. Okay, the investment cost divided by the usage for the first year is 2000 hours. It gives you the cost per hour as 229.69 per hour. So this is your cumulative cost per hour for the first year. Similarly, find the cumulative cost per hour for the second year. Second year, it's nothing but the cumulative investment is 8 lakh 3,906.25. Okay, you divide it by the cumulative usage till the end of second year is 4000 hours. So you will get the cumulative cost per hour as 200.98 per hour at the end of second year. Okay. Similarly, for the third year, the cumulative investment is 10,62,304 divided by the cumulative usage 6000 gives you 177.05 per hour for the third year. So basically, so what I am trying to say is, if you are going to hold your machine with you for 3 years, say for example 3 years, okay, the cumulative investment cost per hour for the 3 years is 177.05. Okay. Similarly, if you are going to hold your machine with you for 4 years, the cumulative investment cost per hour for the 4 years will be 157.01. Okay. So that is why we are trying to find based on cumulative basis so that we can get a clear picture for the replacement. Okay. So this value indicates the cumulative investment cost for the past 4 years, per hour for the past 4 years. Okay. Now let us calculate the next important component of the equipment cost. It is nothing but your maintenance and the repair cost. Okay. So, as you know, all the costs associated with the repair and the maintenance, like the cost of the labor you engage for the repair work, okay, and the replacement parts, okay, what the cost associated with the replacement parts, everything will come under the maintenance and repair. Okay. So, basically for a very big project site, you may have your own maintenance yard. Okay. You have a maintenance facility and you might have engaged a labor for doing the regular maintenance or the periodic maintenance for your machine. So, the cost associated with those things will be included under the maintenance and the repair cost. So, as you know, with increase in the age of the machine, you can see that the maintenance and the repair cost will increase. Okay. But in the previous table, do you remember? So, the investment cost, you can see with increase in age of the machine, your cumulative cost per hour is decreasing. Okay. As I told you the reason. So, when the investment cost is distributed over a greater period, okay, when the cost is distributed over a greater period, you can see that the cost will reduce. As the usage is increasing, you can see that the cost is reducing with the time. But in the case of operating cost, the maintenance and repair cost, downtime cost, you can see that your cost will increase with the age of the machine. Okay. So, that thing you have to note it very carefully. Now, let us calculate the maintenance and the repair cost. So, this table I showed you already. This is the input table, input values given in the question. Every year maintenance and the repair cost is given. You can see that the maintenance and the repair cost is increasing with the time duration. Downtime cost is also given, it is increasing with the age of the machine. Okay. The productivity loss is increasing. Okay. There is a loss in productivity with age of the machine, and the obsolescence factor is increasing with the age of the machine. Let us calculate all these costs, okay, in the upcoming slides. The first one we are going to calculate is your maintenance and the repair cost. So, every year annual maintenance and repair cost is given. Now, you find the cumulative cost, because everything is done on cumulative basis. Find the cumulative maintenance and the repair cost for every year. You just add it. Okay. The first year the cost with the second year cost, if you add it. Okay. So, you are going to add the first year the maintenance and repair cost. Okay. So, with the second year cost, if you add, you will get the cumulative cost at the end of second year. Similarly, cumulative cost at the end of second year, add it with the cost of third year, you will get the cumulative cost at the end of third year. Okay. So, like that you keep on calculating. You know the cumulative usage of machine, every year it is 2000 hours, we can add it. Now, similarly, you find the cumulative cost per hour. You are going to divide the third column by the fourth column to get the cumulative cost per hour. It is nothing but 1,13,200 divided by the usage of machine. For the first year is 2000 hours, it gives you 56.6 rupees per hour for the first year. Similarly, for the second year, 3,96,700 divided by 4000 gives you 99.17 rupees per hour for the second year. So, if you are going to hold your machine for 2 years, the cumulative repair and maintenance cost will be 99.17 per hour for the past 2 years. Similarly, if you are going to hold it for 3 years, your cumulative repair and maintenance will be 123.28 rupees per hour for the past 3 years. Okay. So, that is why we are calculating on the cumulative basis. And you can clearly see that your maintenance and the repair cost is increasing as the age of the machine increases. Now, we are going to calculate the downtime cost of the machine. Okay. So, because of non-availability of the machine for the productive job, what is the cost associated with that we are going to calculate. So, the downtime percentage is given in the input as the input data for this problem. So, we are going to calculate the downtime cost as a percentage of the equipment cost. So, equipment cost is given as approximately 900 rupees per hour. Okay. So, now you calculate the downtime cost. Okay. So, downtime cost per hour equal to 3% of your equipment cost. Equipment cost is nothing but 900 rupees per hour. Okay. So, 3 by 100 into 900, it gives you the downtime cost is rupees 27 per hour. Okay. Downtime cost is rupees 27 per hour. But your machine is going to operate in a year for 2000 hours. So, what is your yearly downtime cost? Yearly downtime cost for the first year is 27 multiplied by 2000, okay, gives you 54,000 rupees. Okay. This is your per year in the sense for the first year. Okay. 54,000 rupees for the first year is your downtime cost. Okay. Similarly, calculate the downtime cost. Let us calculate for the second year. The second year, the downtime percentage is 6%. Okay. So, downtime cost is 6% of your equipment cost. Equipment cost is 900 rupees per hour. So, 6 by 100 into 900 is rupees 54 per hour. So, yearly downtime cost equal to 54 multiplied by 2000. So, 54 multiplied, the usage of the machine, yearly usage is 2000 hours. So, 54 multiplied by 2000 gives you 1,08,000. So, 1,08,000 rupees is your downtime cost for the second year. Similarly, you calculate the downtime cost for all the years for the entire life of the machine. Okay. Now, you find the cumulative downtime cost. Everything is done on cumulative basis. So, find the cumulative downtime cost. So, by adding it. So, 54,000 plus 108, 1,08,000 gives you 1,62,000. 1,62,000 plus 1,62,000 gives you 3,24,000 for the third year. So, like that you keep on adding it, you will get the cumulative cost. Okay. So, now you know the cumulative usage, every year it is going to be 2000 hours, you add it. Now, the cumulative cost per hour you can calculate by dividing the 6th column by the 7th column. Okay. Values 54,000 is your cumulative downtime cost for the first year, divided by cumulative usage for the first year is 2000. That will give you the cumulative downtime cost per hour as 27 per hour. Okay, for the first year. Similarly, for the second year, it is 1,62,000 divided by 4,000, because for second year the usage is 4,000. Okay. So, now the cumulative cost per hour is 40 rupees, 40.5 per hour. Okay. So, like that you calculate these values for all the years. Okay. We are just going to divide the 6th column by the 7th column value. Okay. You will get this the cumulative cost per hour. Now, you have to account for the loss in productivity. So, the loss in productivity is also going to result in increase in the downtime cost of the machine. So, as we discussed earlier, the loss of productivity results in increase in production cost, because your machine has spent the time in the repair yard. So, after the service, when it comes back to the project site, okay, we will be behind the project schedule. So, to bring your productivity back to the original production rate, we need to engage the machine for more number of operating hours, or we need to even increase the number of machines, or we may need to increase the number of workers. Okay. So, to bring back the productivity to the original production rate. Okay. So, for that we have to increase, we have to spend some more cost, some more money we have to spend. So, that results in some increase in cost, okay, due to downtime. So, that is what is called as productivity adjusted cumulative downtime cost per hour. That is what we are going to find here. Productivity adjusted cumulative cost per hour, we are going to find that. Okay. So, you know that the productivity factor is given as an input data in this problem. So, for the first year there is no change at all, okay, but for the second year there is loss in productivity 0.98. So, I want to see my 40.5 is my cost per hour, okay, the productivity corresponding is 0.98. To bring back this productivity to 1, I need to spend some additional cost, 40.5 divided by 0.98. Okay. So, that gives me the actual cost 41.33. Okay. So, this is an increase in cost I am facing due to the downtime. To bring back my productivity to the original production rate, I need to spend some more efforts or cost. Okay. So, that is what is productivity adjusted downtime cost. Okay. So, you are going to find that by dividing this the 8th column by 9th column, you will get this. Okay. 54 divided by 0.97, I will get 55.67. 65.25 divided by 0.95, you get 68.68. Okay. So, this gives you productivity adjusted cumulative cost per hour. Okay. So, you have calculated the downtime cost. So, let us now move on to the next cost, which is nothing but your obsolescence cost. So, every year your obsolescence factor is increasing as the machine is becoming more obsolete. So, here we are trying to calculate the cost increase resulting from retaining the old machine with us, which is producing at a lower productivity rate. So, your machine is being subjected to wear and tear as the age of the machine is increasing. Okay. So, because of that there will be some loss in productivity of the machine, there will be increase in maintenance and the repair costs associated with the machine. Okay. But there may be many competitive models in the market available with a better productivity at a lower cost, okay, and even with better advanced technological features. Okay. So, instead of switching over to the new machine, as we are just clinging on to the old machine, what is the increase in cost we are facing? That is what is the obsolescence cost. That is what we are calculating now. Okay. Cost increase resulting from retaining the old equipment which produce at lower rate. Okay. So, that is what we are going to calculate here. Okay. So, this obsolescence factor is also calculated as a percentage of the equipment cost. Okay. Equipment cost, you know, approximately, okay, 900 rupees per hour, we are going to use that value here. Okay. So, calculate the obsolescence cost for every year. First year obsolescence is 0. So, let us calculate it for the second year. It is nothing but obsolescence factor is 0.05 multiplied by the equipment cost is 900. So, 0.05 multiplied by 900 gives you the obsolescence cost 45 rupees per hour obsolescence cost. Your equipment cost is 900 rupees per hour, your obsolescence cost is 45 rupees per hour. Okay. So, this is hourly basis. Now, you have to calculate for the entire year. So, yearly obsolescence cost for the first year, yearly obsolescence cost for the first year is 45 multiplied by 2000. So, 45 multiplied by 2000 gives you the obsolescence cost as 90,000 for the first year. Now, similarly, calculate the obsolescence cost for the second year. The obsolescence factor is 0.12 for the second year multiplied by the equipment cost 0.12 into 900 gives you 108 per hour. This is your obsolescence cost. Okay, your equipment cost is 900 per hour, but your obsolescence cost is 108 per hour. Now, find the yearly obsolescence cost. Yearly obsolescence cost is nothing but 108 per hour multiplied by yearly usage is 2000 hours. So, that gives you the obsolescence cost for the third year as the 2 lakh, okay, 2,16,000. Okay, this is for the third year. This is for the third year. Now, you find the cumulative obsolescence cost. Okay, you add it. Okay, you add it. You will get the cumulative obsolescence cost for every year. You know the cumulative usages for every year. It is 2000 hours. So, you can add it. Now, similarly, you find the cumulative cost per hour. Okay. So, the cumulative cost per hour is going to be nothing but column 6 divided by column 7. Okay, as we did for the earlier course, the same methodology we are going to follow here. So, the obsolescence cost for the second year is nothing but the cumulative cost is 90,000 divided by the usage of the machine. For 2 years, it is 4000 hours. Okay. So, that gives me the value as 22.5 per hour for 2 years. Okay. Similarly, for the third year, it is nothing but you can see the cumulative cost is 3,06,000 divided by 6,000 is the usage of machine for 3 years. That gives me the cumulative obsolescence cost as 50 rupees per hour for the past 3 years. Okay. It means this 51 rupees per hour reflects the obsolescence cost for the past 3 years. If you are going to hold your machine with you for 3 years, your obsolescence cost per hour for 3 years will be 51 rupees. Okay. So, that is what you mean on cumulative basis. Okay. So, the same way you calculate the cumulative cost per hour for the entire life of the machine. So, you can see that the obsolescence cost is increasing with the time. Okay. Similarly, your downtime cost also, the earlier table you can see it is increasing with the time. Okay. Increasing with the age of the machine. Okay. Now, let us summarize all the costs we have calculated so far so that we can estimate what is the optimum replacement type of the machine or what is the economic life of the machine. Okay. So, the first is depreciation and the replacement cost. Okay. So, I have just summarized the values we have estimated for the 8 years. Similarly, the investment cost, similarly the maintenance and repair cost for all the 8 years, downtime cost for all the 8 years, then the obsolescence cost for all the 8 years. Okay. So, one thing you note here is your depreciation cost, okay, it is decreasing. Okay. Depreciation cost is decreasing with the age of machine. Investment cost is also decreasing with the age of machine. As the investment cost is getting distributed over a greater life, greater usage, your cost is getting reduced per hour. but your maintenance and the repair cost as the machine gets older, it is increasing. Similarly, your downtime cost is increasing, okay, and your obsolescence cost is increasing with increasing age of the machine. Now, when you add all the total costs, what is the trend we will see? Okay. So, for the first year the cost is high, 855.79. Now, the cost is reducing, 851.79 for the second year, now still reducing, 849.24 for the third year. For the fourth year it is minimum. Now, again what is happening? Cost starts increasing again. From 844 it is increasing to 849. So, you can see that you are getting a trend like a parabola. Initially the cost is high, then the cost reduces, it reaches a minimum point, then again it starts increasing. Why it starts increasing? You know that because with increase in age of the machine, your maintenance and repair cost is increasing, your downtime cost is increasing, your obsolescence cost is increasing. So, there is an increase in the cost of machine after a particular point, significant increase you can see. Okay. So, beyond fourth year your cost is increasing. Okay. So, now the economic life means the period during which the cost associated with the machine is minimum, that is your economic life. So, during the fourth year the cost is minimum. Okay. So, at the end of fourth year it is advisable to replace your machine. So, the economical life of the machine is fourth year because the minimum cost is 854.31. So, the equipment owner won't prefer to hold a machine when cost associated with the machine is going to be high. Okay. So, beyond the fourth year it is increasing. So, at the end of fourth year it is better to replace the old machine with the new machine. So, if you are not going to replace the old machine with the new machine, if you are still going to hold it for one more year, say fifth year, okay. So, this difference will be the loss in this 849.19 okay, minus 844.31. Okay. So, this difference is going to be your loss. So, this loss per hour, it will be reflected for the entire 5 years. Okay. So, the loss per hour is going to be reflected for the entire 5 years. That is what is the main thing when we do it on a cumulative basis. Okay. So, I hope you understand. So, this loss is not reflected not just in the past 1 year. The loss per hour is going to be reflected in the entire 5 years of the machine. If you are going to retain the machine for 5 years, okay, even beyond the optimum replacement time of the fourth year. If you continue use of the machine for more years beyond the optimum replacement time, the loss is reflected in the every operating hour till you to hold the machine. Okay. So, that you have to note it. So, this is how we estimate the economic life of the machine. So, here we have optimized the productivity with respect to cost, that is why we have gone with minimum cost approach. If you are going to optimize the productivity with respect to profit, then you have to go for maximum profit approach. Okay. You have to find the time period during which the profit is maximum. So, even that approach we will be discussing in the next lecture. Okay. So, this picture, it just shows you the pictorial representation what I discussed in the earlier slide. So, during the initial period, you can see that the cost associated with the machine is slightly high, then the cost starts reducing. As the cost is distributed over a greater period, it starts reducing. Now, it reaches a minimum point and after that it starts significantly increasing. Why this significant increase? It is mainly due to the increase in the operating cost or the maintenance and the repair cost, your downtime cost, your obsolescence cost, everything is increasing significantly. That is why you can see there is a significant increase in cost with increase in age of the machine. It is better to replace the machine at the end of the fourth year. So, okay, the economic life for this machine is fourth year. So, this picture shows you the breakup of all the cost trend. So, we are finding the variation between the cost of the machine with the usage of the machine. So, obviously, your depreciation, your investment cost, all your ownership cost is decreasing with the time. Okay. As I told you earlier, as these costs are getting distributed over greater usage, over greater hours, the cost per hour is getting reduced. Okay. So, your repair and the maintenance cost, as the machine gets older, you can see that the cost starts increasing significantly. Similarly, when you add both, this is your ownership cost, this is your operating cost. When you add both, you get your total cost. Okay. This is your total cost. So, if you see the total cost curves, initially it is high, then it reduces, reaches a minimum point, then it again starts increasing. Okay, so this is your economic point, minimum point. This is the economic life of the machine. You are supposed to replace the machine at the end of this time. Okay, so that is what is explained here. The cumulative cost per operating hour is high at the first when the initial investment is distributed over few hours. Okay, so you can see that the initial investment, when it is distributed over a few hours, the cost is high. Okay, so then as the cumulative cost per hour decreases as the working period increases. Okay, as the working period increases, you can see the cumulative cost is decreasing. So the repair cost increases with increasing age. Okay, it is increasing with increasing age. So when the cumulative cost is the minimum point, it means the equipment has reached the end of the economic life. So it has reached the minimum point here. So this is your economic life. So this is the optimum replacement time for your machine. So what is economic life? There are different terminologies used for that. We can call it as economic service life or economic life or minimum cost life. So this is the number of years at which the cumulative cost per operating hour of the owning and operating equipment is minimum. Considering the most current cost estimates over all the possible years over which the asset may provide desired service. As I told you, you should consider all the components associated with the cost so that we can make a accurate estimation of the replacement time of the machine. Okay, so this indicates, the economic life indicates that asset should be replaced to minimize the cost associated with the machine. So we have come to the end of this lecture 6. Okay, so let me summarize what I have discussed so far. So basically, we know the need for replacement of the machine. So why should we replace the old machine with a new machine? Because your old machine, because of the wear and tear, it may be showing reduced performance, reduced productivity, and there may be a sudden increment in your productivity requirement in your project site. So there may be some altered requirements. You may face some increment in the production requirement. Okay, so for that you have to replace the old machine with a new machine which has a better productivity than your old machine. Okay, and obviously your machine would have become obsolete because of many competitive models available in the market. Okay, so there are different reasons which justifies the replacement of the old machines with the new machine. Okay, so economic life is a time at which your cumulative cost per operating hour of the machine is minimum. Okay, so that is what we have discussed. And one thing we have to note here, though we consider most of the cost associated with the machine, but one thing what we have missed in the previous analysis is we did not consider the time value of the money. When you do not consider the time value of the money, obviously your cost estimate or the decision is going to be only approximate. Okay, so as we discussed earlier the lectures, we should consider the timing of the cash flows and convert all the cash flows which are occurring at different time interval into equivalent cash flows at a particular time period and make a rational comparison. Okay, so that only gives you an accurate estimate. So that this method we are going to do in the upcoming lecture. So to get the accurate estimate, we have to consider the timing of the cash flows. Okay, so the main objective of determining the economic life is to decide the optimum replacement time of the machine. It is not advisable to keep inefficient and obsolete machine, even though your machine may be functioning at your project site. Okay, it is not totally broken down. Even though it is functioning, it is not advisable to just continue with the usage of old machine. Okay, so from profitable equipment management perspective, we should not just cling on to the old machine when its productivity is less. We should see for the optimum replacement time and replace it with a newer productivity model, newer model which is available in the market with a better productivity. Okay, so for the equipment replacement analysis, we are supposed to consider all the cost, as I mentioned earlier, include the depreciation cost, effect of inflation, investment cost, maintenance and repair, downtime, obsolescence. Everything should be considered for the accurate estimation of the optimum replacement time. So these are the points we should keep in mind when you do the replacement analysis. So these are the references. Okay, these are the textbooks which I recommend for the preparation related to this topic. So basically in the lecture 7, in the upcoming lecture, I will be discussing on the equipment replacement analysis. Okay, so in that we will be discussing some more different approaches, like how to compare the defender and a challenger. Okay, so hope you remember what is defender and a challenger. Defender is a current machine which you are possessing at your site, and challenger is your proposed machine which you are planning for replacement. Okay, so now we have determined what is the optimum replacement time for the current machine. Now you have to see what is the best alternative available for the replacement. Okay, whether the challenger is suitable for replacement or not, that we have to compare. Okay, so by comparing the cost of defender and challenger, we will decide whether the challenger is suitable for replacement or not, and we will also see what is the optimum replacement of the defender with the challenger. Okay, so other different approaches under a replacement analysis will be discussed in the upcoming lecture. Thank you.